everyone, welcome to our first edition of the Interactive Visualization of Data workshop. My name is Tim Lee. I work with Arif and Sheldon on the team by the same name, Interactive Visualization. It's a mouthful, I know. I even have problems saying it sometimes. But we'll go through some pretty cool exercises today, mainly in Unity, with some helper tools on the side. And I guess we can also maybe go around to do some introductions. So I'll start. I am a software engineer / architect by training. We develop tools internally for internal and external uses. And we also, and our focus is heavily on VR and AR types of exercises. And I'll pass it on to, where's the mute button? So we're all in the same room, so I have to mute myself before passing it on to maybe Arif.
Hey, I'm Arif, also working with Tim on the same stuff, architect by training though. Yeah, AR, VR, XR, app development, etc.
Did that work for everyone? Can you hear him? Okay, good. Sorry. We should have been in 3 separate rooms, but we thought it would be more collaborative if we can be in the same room. So, and I'm Sheldon. My background is in electrical and computer engineering. I don't really have architecture educational background, but I have been working in and around shop projects for 3 years. And mostly I work with electronics hardware, environmental sensors and such, but also dabbling in data analysis and visualization. Cool, maybe we'll go around the room also. Andres, you wanna do the honors?
Hi, how are you, everybody? My name is Andres. I'm with Core Studio, one of the senior computational designers.
Nice. Elgin? Oh, I think your sound is not working, Elgin.
Okay, you go for next. Okay.
Oh, I can hear you now.
You hear me? Okay.
Yeah.
I was making also the sign. This is Elchin. I'm also part of the Core Studio. I'm a senior associate applications developer, and my background is also architecture. Happy to be here. Thank you.
Long-time friend. Mike?
Hey, I'm Mike Talbot. I work for an architecture firm in Baltimore, Maryland. I'm a software engineer and architect by trade. I've spent the last 10 years working in AR and VR.
Awesome. Chris?
Chris Grammons. I'm the design technology manager at Miller Hall in Seattle. And we're just kind of starting to dabble into AR and VR for different initiatives that we have in the office. So I'm here just to learn from you guys.
Yeah, absolutely. Awesome. Nico?
Hey, my name is Nico Azell. My background's in landscape architecture and planning, and I'm a senior software developer and resilience consultant here with Core Studio.
Anders?
I am Anders from Foster & Partners. I'm a part of the Applied R&D team, and I'm super excited to see what you guys are up to.
Cool. Ahmed?
Hi, I'm Ahmad from the Archangles Group in New York. I'm a design technology specialist, and I also do a lot of custom AR and VR with Unity. So I'm also excited to see what you guys are doing with it from a data visualization standpoint.
Cool. Sorry that I mispronounced your name.
No, you're good.
Knut?
Yeah, hi, I'm Knut. I'm a structural engineer from Royal Haskoning DHV in the Netherlands. But now I do more software development, application development.
Very cool. Libni?
Yeah, Libne here, computational design lead in White Architecture in Sweden. So nice to join you guys.
Ashkan?
Hi everyone, I'm Ashkan Ratnia. I'm a computational designer and software developer at Galson RTKL. Nice to meet you all.
Ananth? Anna?
All right, 1 second. Is it working now? Great. Sorry, had trouble coming off mute. I'm Anant. I work for Arab. I am a data scientist and data strategist. So any type of data visualization is kind of exciting and interesting to me, and really excited to learn more about how to do that in Unity.
Cool. Sam?
Hi, this is me. Yeah, this is Sam Tomasetti. I'm the Associate VP of VDC Technology from AECtech Engineering. And yeah, I do have some backgrounds in data analysis, and I'm very interested in learning more here. Thanks, guys.
Cool. Melissa?
Yeah, hi, I'm Melissa. I'm a civil engineer from France, and yeah, I'm interested in learning new computational design related topics in the industry.
Welcome. Giacomo? Giacomo, are you there? Okay, we'll move on to maybe Matthew.
Hey, my name is Matthew Brough. I'm a design computation specialist with Bayer Blinder Bell here in New York, and just super interested to see what you guys have to present.
Awesome. Nicholas?
Hey, I'm Nicholas. I'm also from Bayer Blinder Bell. I'm an architect and the director of design and construction technology here. And data visualization is increasingly of interest to us. And so we're really excited about what that holds in store for us for 2023. So excited to see what you guys have.
Great. Mia?
Hi, my name is Mia. I work at Grimshaw at the moment. I'm working mostly on the Revit side of things. So this will be a new experience for me.
Cool. Veronica?
Hi, everyone. I'm Veronica Quintero. I'm KPF's BIM practice manager here in New York, and looking forward to the session.
Cool. Anthony?
Good afternoon, everyone. Anthony Thompson from Target, background in architecture, construction, and technology. And I'm here based in New York and very excited about this class. Thank you for having me.
Cool. Last but not least, Mohit. I'm mispronouncing your name. Sorry about that.
No, you're pronouncing it correctly. Hi, my name is Mohit. I am a project designer with Project Frog. We're based in San Francisco and we are a prefab company. Nice to join you guys.
Thank you. All right, let me reshare my screen. Yeah, so I guess we'll dive right in. So I see that a lot of people have, you know, either VR, AR experience or even with Unity. So, excuse me, still kind of getting over a cough, but hopefully it's not too disruptive. Yeah, so I was saying that A lot of people have very similar backgrounds as ours. So maybe part of the tutorial or workshop might be a little redundant, but let us know if you already know the subject. But we also have a variety of backgrounds, so maybe it's okay. But just to preface why or why there's a need and why is it kind of important at this time about real-time and interactive visualization. It is a very effective way to communicate. As you can see on the right there on the slides, this is an internal tool that we built on mobile devices. So it's both on iOS and Android. And because it's very, like, we started with the idea of building a cocktail app for the office. That's our way of presenting our projects. It started out as that, and then it kind of started build on its own into this, a tool to visualize, whatever we kind of do around the office. So on the right side, you have the construction, we call it the construction status tracker. So that's our project here in Brooklyn. It's already topped out, so we're finishing up on the facade right now. But so the main idea is that we are tracking, as you can tell, like this is right now the section cut view, but you can switch to this mode where it tells you at what height we're at, and what floor and facade panels we have installed. And those are kind of, just a quick and easy way to communicate the status of the project. And barrier to entry has been lowered. So everyone has a pretty powerful personal mobile device these days. So these, basically this was built on Unity Engine, and all the mobile devices are pretty powerful enough to handle a lot of these more computationally heavy objects or 3D assets. So it's also because of all the spread of the powerful mobile devices, and also being able to build apps straight out from game engines that has allowed us to move forward in this space. And efficiency is another one, because basically you can carry your mobile device onto the site, and then you can, in the case of construction status tracking, basically you just have to change up in a spreadsheet where the status or the most current installed pieces, and then it updates automatically on the front end. Yeah, feel free to jump in and ask any questions at any given time. So in this workshop, we'll cover how to build a mobile or even desktop app in Unity, which sounds like many of you might already know, and how to tie an app to a simple and agile back end solution for real-time data visualization. And then the two things we'll focus on are RESTful API. We'll show how to tie into, oops, someone's waiting in the waiting room. Sorry about that. There's 3 people. Yeah, so I was saying that we'll demonstrate 2 ways of tying into, 2 kind of mainstream, or maybe not mainstream, but 2 possible backend solutions. One is through Airtable, which is pretty straight up simple RESTful API. And the other one is MQTT, using the publish subscribe model that's even more real time than what a RESTful API allows. Yeah, this diagram is just to illustrate what we'll essentially do today. The data side is on your left, or sorry, on your right. We basically use Airtable as the database component here, and the RESTful API to talk to our app. And the MQTT part is basically it's a client or like a broker that talks to IoT sensors, which we'll also touch on today. If you haven't already, please go download, if you want to follow along, that is, please go download Unity Hub, which will then allow you to download the editor for Unity game engine, and make sure you download the latest version. I mean, there's also 2022, but I think that's still kind of in beta. So, or the 2021 is more stable. So 2021.3.12 or 1.1 would do. And also after that, you would want to clone the GitHub repo. You want to clone the repo so that the coursework, the demo scene is already there. Yeah, so as I was saying, for those who don't know this already, Unity is a game engine and application development platform. It uses real-time rendering to make interactive software and applications for mobile, desktop, AR, VR, XR, etc. So I guess the main difference of Unity from all the traditional BIM softwares and modeling tools is that it's really good for so by real time we mean that you are able to push and pull. Well, it makes it easy for you to push and pull data on a what I'm trying to say. I think what I'm trying to say is traditionally you work on PCs or Macs or whatever, desktops, right? So these machines are pretty powerful. They're powerful enough to handle, like gaming and all that. But now we're kind of moving into the space of more, like with mobile devices. If you have the geometries, the 3D assets light enough, you're able to, visualize things on your mobile devices, and it's just a quicker way of communication. And what's really cool about Unity is that it, it works with a lot of different file formats, and we'll show you in just a bit on that. And it uses C# to script, which is a pretty, for non-engineers, it might be a steep learning curve, but compared to other more low-level languages, it's actually pretty good. Unity allows you to build out apps to different platforms. So you only have to you have to build the app once, and then you can build out to all these platforms. Lastly, so I guess we'll begin the workshop with bringing in a Rhino model into Unity, because Unity is not really a good modeling tool. It's basically for, again, real-time visualization or like a gaming engine. So you would normally model in other softwares, Blender, Rhino, all the other stuff, and then you bring it into Unity to work on the visualization part. So today's exercise we'll demonstrate. Sorry. We'll demonstrate. We're trying to kind of replicate the construction status exercise we've done in the past. So basically, you can imagine, you know, if you want to keep track of a building that you're making, right? You then kind of break out the different elements within the project that you want to keep track of. So, for instance, in our case, with the 9 decal project here in Brooklyn, it's a tower. So we want to keep track of which floor we're on, including the slab structure and the facade, right? So that's how we kind of broke down this project, and that's how we're going to demonstrate. But you have a lot of flexibility there that you can play with, you know, in kind of, you can manipulate that in Rhino and in Airtable, depending on how you want to break down your project. Yeah, Arf, maybe you want to jump in right here.
Yeah. Also, I don't know if Tim, I think we already said, but just to be clear, we're going to go through all these steps more in detail after the deck. So no worries, this isn't the part you need to be following along with yet. But another important part of our pipeline is when bringing things in from other more typical AEC applications to Unity. Since Unity is a game engine, and since a lot of the apps that we're developing are focused towards mobile and kind of like lightweight, quick loading applications, we tend to have to reduce the level of detail that you might be typical, which is kind of, it's just part of the pipeline right now. And we hope that, you know, as technology gets more powerful, then maybe we can keep having higher res models. And there definitely are ways there, like we have done experiments using very high level of detail models in our mobile apps, but generally those are less preferable to when we can do something like, sorry, if Tim goes back one slide. So you see this is very dumbed down because it's for the purpose of the workshop, but it's something where like maybe with what we want to communicate, we only need to show a very simplified version of the curtain wall and a very simplified version of the floor slab and core, and we can achieve a very effective level of visualization without having, you know, every assembly that you might have in a Revit model. Sorry. But yeah, so in case you couldn't hear, I was basically talking about how in the slide before we were showing a much more simplified version of an architectural model. So the process for that was taking something from Rhino and Revit, putting it in Rhino and running through an optimization workflow, which is kind of diagrammed on the right, where you can see the same mesh can be represented with a variety of different levels of detail and especially levels of polygon count. So we could go more in depth with this in another presentation, but for the purposes of this, it's just important to know that we have to generally tailor these models a little bit for either mobile application use or for AR, VR. And then also just a quick note on going from Rhino to Unity, we are going to be using FBX export because it integrates into Unity well in terms of like the mesh data and names of materials, but then there's also sort of a live link that'll be maintained, which you'll see more of later.
Yeah, so I guess this is kind of just going over the two different backends, the RESTful API that we'll be using with Airtable, and then the next slide we'll go over more of the MQTT stuff, which is really useful for IoT devices. But yeah, so the basic points are, you know, RESTful APIs are really fast to implement. They're agile. It's usually pretty quick to change things and change endpoints. And, you know, like for those who are not familiar with RESTful API, you know, it's basically, it kind of functions as you're browsing the web, and it's a little bit smarter. And, you know, in our instance, the app we're going to build is the kind of the client app, which contacts the server, which is in this case, Airtable. And it pretty much hits a URL, and then you get back some data, which we'll show you in a bit. And here's what Sheldon will take over. Yeah, so getting into the MQTT protocol, just a little bit of history around it. It was actually created back in 1999 by two IBM engineers. They were trying to implement a protocol to make it possible to communicate with oil pipelines in remote locations via satellite. So they really needed something that was would allow them to work with minimal bandwidth or even power efficiency. And it's kind of designed around having a few parameters, simple implementation, being able to be data agnostic, and also have a framework of being able to confirm if data is delivered or not. And around 2011, all of that went open source, went under the Eclipse project, and has also now become an OASIS standard as a open source protocol. It's been pretty much adapted by the IoT community and had features built up over the years, especially considering security. So pretty much MQTT uses the publish subscribe model to communicate between devices and applications. Essentially, when you publish a message, you just select a topic, which you can have multiple subscribers that are set up to receive the message. And clients can subscribe to and publish multiple topics at like any time in the session. And the way that the topics are structured are kind of like how we have folders where we use these slashes to have a sense of hierarchy. And that allows you to have sort of filtering around the topics that you're subscribing to and receiving, or even publishing. And so getting into a little bit of the terminology, just the common terms that I'll be throwing around in the next few minutes. You have the client, which is whatever device or application that is connecting to the broker or server over the network. Then you have the broker itself, which is just software that would be running on a machine that is actually handling the incoming messages and forwarding them to whatever clients are subscribed. And then the topics. So these can be strings with this hierarchical structure, which you set up the slashes, and you can also have other expressions like a hash symbol or a plus to use as wildcards if you wanted to subscribe to multiple topics, or even if you don't have a topic set up already, you can kind of have clients subscribe to topics with the hash symbol and have other people publish, where you can pretty much listen to, or you'll receive all topics under that wildcard, even though you're not directly subscribed to them. And then other than that, it's just the connection and disconnection of the clients to the servers. There are some protocols within the broker to manage, or at least be aware of what clients are connected when they are connected, and the broker can even take action if someone is disconnected from the network. And just some important points to note on the protocol, on the MQTT protocol. You don't send messages directly from client to client. You're just publishing directly to the topics, and whatever clients are subscribed to the topics will receive those messages. Yeah, the broker, based on the hierarchy of the topics, the broker can also filter messages itself. Even users that are even clients that are connected, they can be filtered in terms of like what topics they can receive or change. And yeah, that's more or less it. Yeah. Just a quick comparison between the two. Basically, MQTT would be a little simpler, a little faster than HTTP, and is more or less there will be a difference in like use case as opposed to like one over the other. Typically, if you have a lot of devices that are sharing data between each other, or you know, you have low bandwidth latency, or you need your project to run off battery power. Those are all like good reasons that you could use MQTT. But if you have more complex data, or even like historical data, it might be better to use HTTP protocol. And yeah. I think we might have failed to mention that. So this workshop will work on, you know, the construction status tracking, but at the same time, we are going to use sensors on a phone to send over to the receiving app. So we'll be visualizing, you know, the API, the Airtable API, RESTful API stuff, and also the IoT kind of equivalent. So essentially, we're using the mobile devices as an IoT sensor in place of that. And yeah, like this is a good way to kind of have a very quick multi-sensing device that like everybody has access to. Yep. Cool. Yeah. For those who maybe join a little or join a bit later, I was saying that if you have time to get Unity installed, that would be great. But we'll probably be diving into Unity in a short second. So let us know if you have any problems finding the right versions or installing it, but it should be pretty straightforward. All the links are up on the Slack channel again, and also on the Google Drive. But if you have successfully downloaded Unity Hub, you should be able to see, and then yeah, if you open it, you should have something like this. And so that would be the first thing you download is Unity Hub. And then under installs, you add. And since I already have this version installed, it's grayed out. But yeah, that would be the under recommended release, and you would install that. And just to show you, I'm assuming most of you are using a PC. So if you don't have Visual Studio Community already installed, you can check this. And then if you want to build out to Android, check that. Windows build support, I would check. If you're a Mac user, you could check iOS. On a PC though, there's really no sense of checking the iOS because you can't build it out. You could simulate it in the editor, but you cannot build it out straight to to iOS devices or even Mac. And then if you just follow through the steps, you should be good to go. Yeah, so I'll probably start from a blank project just to demonstrate. Maybe before we dive into that, we'll kind of touch more on the optimization part of the model, and then bring it into Unity. But just to kind of segue into that, so the reason, one might wonder why we cannot just pull straight from Revit and then upload that model right into Unity. Unity does have a solution to handle that, which is called Unity Reflect. It's a pretty good, basically, you can stream straight from Revit, Rhino, and at like full resolution. It's a service that basically in real time optimizes your model based on, optimizes the model based on the level of detail you need in that particular view. It does require a separate license to use that. So it's like, I guess the barrier to entry is the price tag on the license, and also it does not really work on mobile devices right out of the box. So what we're going to show you is that, as I was describing, part of our workflow these days is trying to present the project maybe on site or in a more agile situation. So you do want to pull it up on your mobile phone to show the client or the owner the project, right? So in order to get there, you would have to optimize the model for it to be performing okay on the mobile devices. If you pull straight from the Revit model, or even sometimes the Rhino model without optimizing, it could get choppy. Yeah. So yeah, let us know if you were able to get Unity installed. But in the meantime, yeah, so I see that Elchin is asking, could you please share the 3D model, the Rhino model as well? Yes, so if you pull from the GitHub repo, it's also in there. Let me show you what that is. So after you pull the repo, it's called Interactive Viz. Go into the assets folder. It should be under 04 models. Sorry. Oh yeah, so if you don't have GitHub desktop client, or you're not familiar with GitHub, you could also go straight to right, we have it. Oh, wait. Sorry. You can go straight to this link. And then just download right here, where it says there's a button that says code, and download the zip file. And then just extract it to a folder where you can work from. And then once you're there, go into Unity Hub and do add. And then you would add that folder wherever you extracted your stuff to. Yes, so Mia is asking, will a recording of this work process be available so that we can watch now and follow along later? So we're being recorded. I'm not sure how TT plans on sharing that recording, but I believe they should be available somehow. I'll get to the bottom of that after this session, but yeah, it's being recorded for sure. Yeah, so kind of going back to where we were. I guess while we were doing this Rhino kind of optimization quick demo, for those who haven't downloaded Unity, this is a good time to do it. And if you don't have Rhino, it doesn't really matter what 3D modeling software you have. The principles are the same. So what we're going to show you, you can do it in Blender and other, like maybe even 3ds Max, whichever software you decide to use. But the file format we'll be demonstrating is FBX, which is a good file format for Unity to consume. So, but I'll let Art drive the demo of the Rhino optimization part.
Just a little switch. Yeah, so like we've already mentioned, this is a dumbed down model, but a couple key things are, well, first, let me just go into shaded view. So in this situation, these are actually just NURBS objects, because this is actually a very simple model that we made for the purpose of this presentation. So you can see they're just very simple extrusions. And if you were to look at like the wireframe structure of it, it's very straightforward usually. And then, so for example, you could just take these models for this purpose and do export and select FBX, which is what we've already done. So hopefully you'll see that when you download the folder. And that will automatically give you, sorry, I think for some reason it's off screen, but basically what it pops up is a meshing dialog where it asks you how many polygons to use. Okay. So basically when you go to export, it'll give you this dialog, which I'm sure if you guys have used Rhino, you've probably seen, but let's see if I can do a quick demo. So for example, if I take this NURB surface and make it into a mesh on the few polygon settings, you see it provides one type of mesh detail. If I do that again on the higher level settings, in this case, it is the same density of mesh just because this shape, like I said, is so simple, but you can imagine if this was a more complicated shape, doing a different meshing process will result in a heavier mesh. But this is kind of one instance where we might have remodeled the building specifically to make a construction status visualization so that it doesn't match up exactly with the design model, but it has the elements that we need. So it's, and again, just a lower polygon model, which helps it load faster on many mobile devices and just gives it more extendability in various use cases. Another thing that will be important going forward and is also interesting in the context of an AEC firm is the idea of structuring a 3D model logically and having a proper layer system in order, which will tie directly into how the RESTful API works, which Tim will get into when we get into Airtable. But I'm sure if any of you have worked in AEC firms, you've probably seen a variety of different design models, and the layer structures are never consistent and they're always kind of all over the place. Or if you're bringing something in from Revit, you have, again, just layer structures that are all over the place. So something that we encounter a lot at shop when we're trying to go between Rhino and Unity is that we need everything to be very clean in terms of layer structure, because it gives us a lot more flexibility when we get into scripting, when we get into using the API calls, etc. So for example, you can see how Tim set up this model to be very logically set up in terms of hierarchy, where you have your north tower, and then it's broken down to slab, glazing, core, and then each each slab is its own layer, each glazing element is its own layer, and then should I get into it?
Yeah, I could maybe say that.
Okay. Yeah, so the good part about doing something like this is that, also just FYI for any of this, if anyone has any questions, please put them in chat if we're going too fast. So the layer structure is kind of arbitrary, but it needs to match what ends up being used in the API call, which again will make sense later. But if we go to export this model as an FBX, I'll call it buildings 2. So I'm going to go with the fewest polygons, since based on what we checked earlier, we're not losing any detail by going by meshing it out as fewest polygons. So you can see that it was exported successfully. And then when we actually go into Unity, so in the Unity interface, at the bottom, you kind of have your whole workspace set up as the project browser. So this matches exactly what you would see in either if you've pulled it from GitHub or if you've unzipped the zip file that Tim mentioned. You see all these different folders, and then the most important one for our purposes is the assets folder. You can see scenes, scripts, materials, models, prefabs, UI, and then various plugins that have installed. This is all pretty standard for a Unity project. But you can see this is where we exported that FBX. But then if we go back to Unity, you can see the same structure down here, which makes it very easy to pull things into your model, to work with scripts and plugins and everything. So if we go into the models folder here, we again see the FBX that was brought in. It's actually just loading it for a second. So I'll let Tim talk about this more in a second, but when you drop in, when you have an FBX here, part of the reason we use it is because if we drop it in, you can see that it comes in as a little package or a prefab in Unity terms. So if I drag the one we just brought in over here, you can see that the layer structure is maintained, and then each of these are what's called a game object in Unity, kind of like a layer in Rhino, but also a bit different. But you can see that the North Tower has core underneath it, and then it has the same kind of object hierarchy, which allows us, when we write scripts, to have a very logical method of selecting, because a lot of what we do, we're selecting children of a parent game object, and then again, Tim can talk about these elements up here a little more, but the essential idea is that as long as things maintain the same layer hierarchy, then we can update things and our scripts will continue to run and not just be one-off scripts for a specific model, but can be extended to various other models. And then I guess another thing just quickly to show that's pretty powerful in Unity is if, for example, I added a model to this FBX, and again, hit export, and then overwrote the that same FBX. The model updates in real time, and that provides a link between the Rhino model or the exported FBX and the Unity model. But I'll delete that now.
Thanks, Arif. And maybe as he was talking through this, I thought it would be a good segue into, kind of introducing Unity as a tool and just kind of familiarize ourselves with the UI. And maybe what I'll do is I will start a new project to demonstrate how I even got here. But if you want to follow along, is probably good. But with the repo, you can also just pull the project up directly. But let's start fresh. So for our purposes, we want to do 3D, and we'll just name it whatever. I don't know. Then create. I hope running 2 instances of Unity is not going to break my Zoom call. Again, let us know if you have any problems with anything. But maybe while it's loading, kind of just to add on to what Ark was touching on. The FBX file format is good, as you could see. And I believe it should work with most of the file formats straight from Rhino. As long as, so here's the thing. If you drag, a format that's supported by Unity, you can drag it straight into the scene. So this is called, I guess, these are kind of game engine terms, or Unity specific terms. What a scene is, I guess it's kind of just the base unit of your game, right? You can imagine whatever, like first person shooter or whatever these game engines are good for. So your characters in a scene, that's where you put your 3D assets, and that's where you load your logic and so on and so forth. And for our purposes, you can load multiple scenes at the same time. But for this demo, we're just gonna stick to one. And for this demo, we call it orbit mode because I guess I'll play the app to demonstrate. So this is the kind of the finished product we're kind of shooting for. Right, so the 2 towers I thought would be interesting to kind of have a bigger project as opposed to maybe just tracking 1 tower, and that's kind of common in our use cases. And what you see here is that you have some basic stats on what's been done, and also the flashing ones are the work in progress elements, and the solid elements are the things that have already been done. Oh wait, we have 2 models. That's why it's ghosting on me. I thought I was hallucinating for a second. So also you see these like ghosted elements. That's we kind of came across that when we were working with the project team, where they do want to indicate where the floor plates might go, but they don't want to show that it's been done because they haven't. So that's just kind of a way to put an extra layer on the data we want to visualize. So we have 3 states: not done, is done, and work in progress. So work in progress is the flashing ones are work in progress, and then done is solid, which I think you can see at the bottom here, the floor plate at the bottom, and all the half transparent ones are not done, but they're shown for indication, just to indicate that's where they are.
And this is all being read from.
And so this is, yeah, that's a good point. So this is all being read from Airtable, which we'll get into.
So nothing's being manually designated in in Unity as flashing or not flashing. It's all happening dynamically.
Can't really hear you. Yeah, I think so. Cool. We got some thumbs ups. That's great. I think, is there anything more on Rhino? Yeah, so the live link thing, as I was saying. Oh, sorry, I wasn't aware that the chat was masking out part of the screen. Sorry about the echo. Both of you muted? Yeah, good. Yeah, so as I was saying, while I was on the file format thing, it doesn't really matter which one file format, as long as you save to the same file, at least, with Rhino. If you keep saving to the same file, it should override what's been imported into Unity. So you would see a live update. But, and as Arf was kind of touching on, the concept of a prefab, it's Unity's way of packaging geometries with logic together. And so in this case, if it's an FBX or OBJ or whatever file format Unity supports, they all come in as a prefab. So if you drag the file into the scene, you'll see this this logo, this icon versus the native Unity cube icons. So these are all called game objects, which are kind of the most basic unit in Unity in terms of 3D assets, or and they could be also hosts for your logic. So if you so there's a way to kind of break that link, which is if you right click on that model and then do unpack, it'll break the link. In which case, maybe that works for your workflow where you want to keep different versions of the same thing. So even if you override to the same, actually, that's not true. So if you expand all the way to the most basic unit, it has a link to that, to the geometry inside the file. I'll get into the UI just in a sec. So, all right, you know what I'll do? I'll start fresh from the demo. I think that makes the most sense. So this is what you get after you start a new project. And typically, I mean, this is not typically, but like this is what you get right out of the box. And you'll have the middle part where you have the scene tab and the game tab. I usually separate out the game tab because sometimes it gets tricky to drag it out. So the scene tab is where you manipulate your 3D assets, and the game tab is where you view. That's kind of the end product, so to speak. So that's what you'll see once you build it out to an app. And the scene window will allow you to, kind of go around. You can do you can fly around and manipulate your 3D objects as you like. So this is when you start a new scene, you'll get a main camera and a directional light. Sometimes the directional light is not required, but in our case, I think it's useful. And so kind of going back to our sample scene. Oops. Okay. Right. So there's a component that we included in the repo that allows you to, once you run the app, there's the zoom bar that's in the way. Elchin has a question. Does Unity 3D coordinate system match the Rhino? Yes. So Unity uses metric system. So all the numbers you see are in metric, in meters specifically. So when you export from Rhino, you want to make sure, of course, you all know this, go into units and do meters. And if you do this, the coordinate systems should match, except I think, so when you export as a FBX, right, it's right over this guy. There's the option of map Rhino Z to FBX Y. So I think with FBX right out of the box, you don't need to do that. So to answer your question, basically, after you set the units right, it should match the XYZ coordinates. Actually, yeah, that should be the case. So that's also one other thing that's less tricky about FBXs, because you can get into, I think with OBJs or some other file formats, the X or the Y and Z are flipped, so that you need to make sure the orientation of the model is right once you import it. So where was that? So I was touching on one thing that that's not right out of the box within Unity. It's a plugin that allows you to, what you can imagine. Delete this. Shrub building. Also failed to mention, when you hit play, that means you start the app in a simulated mode within this game engine. And that's when you start seeing things happening. So what I was getting at was, one of the most intuitive way to interact with the model is being able to rotate it around and even zoom in and out. So the plugin we use is called Lean Touch, which is included in the project. And so the version we're providing here in the repo is the free version, since I don't think we are allowed to distribute the paid version. So with the paid version, you're able to zoom in and out and rotate and do more fun stuff. But with the free version, it only allows you to rotate along an axis. But yeah, feel free to download the paid version, because that's more powerful. And here's how you would add on that plugin. So you go to Window, Package Manager, also, it's also good to make an account with Unity. You can stay on the free version if you don't mind, when you build out the app, having the Unity logo on it. Otherwise, it's pretty much the same. And also, it doesn't allow you to peek into the source code of the Unity libraries. But so what I was getting at was there's a lot of already made, the Zoom bar is a little annoying, so you see also the asset store bar, and now it's all online. So it used to be like an in-app browser, but you can search online. If you click on this and just type in Lean Touch, and there's a free version and a paid version. And if you are signed in with your user account, and once you've downloaded it before, it should also pop up under Window Package Manager, and then you can import it from there. You might have to download it first and then import it. Yeah, so that's just kind of a nifty tool to have to allow you to do more with the model. I guess it's not necessary, but it would be kind of a moot point if you have this kind of cool visualization, but you can't change the view on it because of the limitations of just not having that option. Right? So, and I wish I'm on my laptop. Wish I had two screens to work on. Anyway, yeah, so after you start a new scene, the easiest way to, okay, I should also import that Lean Touch component. And after you select import, because I've already downloaded it once, it's in memory or on the hard drive, it's imported. Okay. Now it's imported. It just created this plugins folder under assets. So really quickly, just to go over some basics of Unity. So this is the scene window we're at that I have described. And then the game window is what the end user will see at the end. And then this is the scene hierarchy, where it's kind of like the comparable to Rhino's, layers window. And then here you have the file explorer equivalent, the project viewer, or whatever it's called. And one thing I like to do usually is there's a slider right down here. I usually slide it all the way to the left, so I get the detailed view of the folders and the files, because the icons could get, like, I think if you have a long file name, it gets truncated, but this way everything is showing, just like the this pane right here. And so whatever is under the assets folder in this pane are actual folders in there's an equivalent in your file structure. Okay, yeah. So whatever's under assets should be also under assets here. And then these are the folders that fall under here. And then whatever's under packages, these are kind of Unity internal dependencies, which are actually in a JSON file. So these are the dependencies that are kind of internal to Unity, the Unity engine. So these folders are, okay, so these folders are kind of hidden away somewhere, and you never really want to manipulate the packages directly unless you know exactly what you're doing. But so the plugin, and then the plugin could come in two major different ways. One is through a straight up file import, and the other one is through packages, where if you go back to package manager, and a lot of these guys, if you import it, you won't see additional files under assets. So that, I don't know if that's really helpful for, if you're a beginner, but if you really dive deep into Unity, that's something to note, because that'll help you. Sometimes you'll have like conflicts and whatnot in different plugins. It's one way to know where to look, basically. But yeah, so after you familiarize yourself with the UI, this is the scene, right? We just created a scene, and the main camera is basically so the game panel is showing whatever you're seeing through this main camera, and each scene would need a main camera to be able to show anything. So let's say and here's how you would create any 3D assets, and even so the library we just brought in, Lean Touch, this is also how you would kind of plug that into this scene. So before that, without Lean Touch, you won't be able to like spin around in the scene, but let's see. So right now the main camera is at, I think. Also, if you ever like click on one object, if you hit F, it'll like try to zoom in on it. Also, another helpful trick is that I'm more used to the older version of Unity, so I don't know where that thing is. Anyway, so here's the camera, right? So if we kind of manipulate where the location is, drag it kind of farther from the origin. You can't really tell from here because it's just a static image. And I kind of, I'm not too big of a fan of that horizon look, because you can tell immediately it's done, something is done in Unity. But yeah, so what I was going to say is we can create, some primitive geometries right in the scene, and you see what I just did. I dropped a cube, and you're starting to see that thing through the camera. And if I rotate the camera a little bit, you'll see the cube moving along with it. If I zoom in or move the camera more to the object. So if I hit play now, right, it doesn't do anything. It's not dynamic. I can't rotate. I can't really do anything with the object. So this is when we introduce Lean Touch into the equation. Usually, so in the purpose of this guy, we would create an empty game object. We'll just call it camera root. And so I'm gonna make this the parent of the camera. So I'm gonna drag, and this is how you make it the child, which is pretty intuitive. You just drag the child object onto the parent object, and then it'll automatically make it a child of that object. And so once you've done that, I'm also going to, so you see on the right-hand side, this is called the inspector panel, right? So this is where all the, sorry, all the scripts and the logic would live. So if you click on Lean Touch, here's basically each of these components is a script that are compiled in the editor. So, so in order for Lean Touch to work, first you have to create a Lean Touch game object by right-clicking game object, Lean Touch, and that's it. And then secondly, you have to add, if you do add component on the camera root and do Lean, it's called twist rotate axis. And by default, it's gonna rotate along the y-axis, which is in most game engines, it's the axis that points up, not point away from the camera. So this is what we want, and if we hit play now. Oh yeah, right. We are forgetting one more thing. So in order for any input, like meaning like clicks and clicks and interactions to work, you would need to add in this thing called the event system as well. And it falls under game object UI event system. And I believe that's all you need to do for to make it work. Thanks, Sheldon. Totally forgot about that. Okay. So it's not quite working yet. Let me see what I'm missing from the demo scene. Oh, sorry, I totally forgot that the so that's also important. So exactly where you attach the script to. I thought camera root was the place, but for this particular script to work, so this is the free, again, this is the free version, and we use the paid version, and this is where we would attach the paid version script to. But in this case, we actually we're not going to rotate the camera in this case. We're rotating the geometry itself. So you need to add the script to the geometry, and then this should work. Yeah, it's on the model. Thank you, Mike. And of course, it's not working. Very strange. I don't think we would need an extra layer of game object to make it work. Huh? Oh, right. Okay. Thanks. Yeah, that's it. So, sorry. You would also, because we're on the editor, we're not building it out yet. We would need this thing called the Lean Touch Simulator, which will simulate your touches on the screen. And also as a to also make it work, you would need, when you hit play, So you would add that script to the same, to that same game object as the lean touch, where the lean touch script is attached, and you just add lean touch simulator. And so you would hold down on your control key, and then you can start to click on the screen and hold down your left key on your mouse to rotate. Yeah, so that's already like the first step to, you know, start manipulating the view and the object in the scene. And, you know, what we can do now, since I think we're ready, is come back to Rhino, right? So we export. Oh yeah, so why not? We can export the cube and remove it, just to demonstrate. So the new project we call is called demo. Go into assets, and how I usually like organizing the files. I just type in the number so that they come in that order always. And let's call it buildings. And again, usually these export lights and views are checked by default. So I would just uncheck them so you don't have to manually delete them again in Unity, and hit OK. And this is pretty simple. So I'm gonna go fewer polygons. So basically we model in NURBS, and now they've been converted into meshes in the FBX format. And also Unity only reads in meshes. Once they're imported, or the file's been saved, you can go straight into the model, or straight to look at the model. And all you have to do is drag it in. It looks like our camera is way too close. So I'm gonna drag it out. Then you're starting to see the full picture. A little bit more out. Great. Okay. Yeah, no, we're probably halfway through the session, so yeah, maybe we can do a break soon. I'll get to a good point and then call it. But yeah, let us know if you're still having problems installing Unity or having any trouble following along. But yeah, so so we just brought in the model, and I don't want to break the link, right? So what I was mentioning before is that if I do this prefab and unpack, you'll notice that the icon turns into a box. And that means if I change anything in Rhino, so it actually doesn't break the link entirely, because in order to break the link entirely, you would do, okay, there's no longer prefab. You would do prefab, unpack completely. But if I just unpack at this level, right, it only unpacks the base level. All these base geometries, they're still linked to meshes within this file. So if you go back to Rhino and then, you know, make some modifications or anything, right? So even if I do this, it's still going to update. So in order to break the link completely, you need to, and you notice just what happened too. It turns into pink, which means it doesn't have any materials applied to it. But previously, they all showed up white because that's just the base material. And the reason being, we've unpacked it right? We have unpacked it at the base level. The geometries are still linked here. If you click on, and what's cool about Unity is if you click on an element and you can find it in the file hierarchy, it'll navigate you to it. So it's still being linked to this geometry within the FBX file. But if you unpack it, it'll break the link. I'm just gonna undo all those steps. So this stays on, and the massive floor plate is not the look I was looking for. That's the north tower, okay? So maybe I've decided, for this app, I'm only showing the south tower. You know what? I'll restart it because that material loss was kind of getting annoying. So I'm gonna just delete the north tower. Sorry. Again. Unpack. I'm gonna unpack at this level, delete the north tower, and just show the south tower. And the reason I'm just to keep everything kind of clean and neat, what we usually do is having a single root object for the 3D assets. And I'm just gonna call it model root. And then I reparent it to that. You don't really have to do this, but I usually tend to separate out the logic straight from the 3D assets. So remember, we applied the lean touch rotate script, just lean rotate axis. Then I'm going to hit save. So again, just to verify, if I hit play, we can rotate. And I guess the origin is a little off now. I'm just gonna, so you see the model root, when I created it, somehow it's at this origin. I can just reset it to be 0 and play it again. The origin is slightly better, still a little off, but it's okay. Maybe it's good enough for this purpose. Yeah, maybe we take a 5-minute break. And for those who have any questions or maybe to troubleshoot, we can stay on and help you. Make it 10? Okay. I guess we'll make it 10 then. And I guess we'll probably speed through the second half because we've spent a lot of time on the basics. And we'll dive into the API calls and MQTT the more. That's where the meat is at. Yeah, well, we'll take a 10, be back at 4:45. Yep. See you guys in a bit. Hey, I see Mike, you have a question. In your slide presentation, the buildings appear to have nice, actually, first of all, Mike, are you here?
Yes, I am. Sorry, I was slow to the mic. Yeah.
No, all good. I just want to make sure I'm not talking to myself. Yeah, high quality lighting. What is your preferred approach for creative? Good lighting for mobile AEC apps, baked, ambient, occlusion, all that. What drove Shop's decision to use Unity over Unreal? So really good questions. Typically, yeah, we would like to bake in the lighting with ambient occlusion. It's like almost a no-brainer you would do that. The ambient occlusion just makes it look so much better. And of course, at today's demo, we're not gonna get into that. And for the model, actually for the model you saw in the demo slide, that doesn't have baked lighting. That's just directional lighting. And we did for a lot of these models, it's still quite heavy after optimization, especially on the facade part. Like there's a lot of just small facade pieces that we cannot optimize, out. So for the mobile apps, we don't have baked lighting. We do have ambient occlusion. And to the second question, what drove shops decision to use Unity over Unreal? So I guess Unity is really good I think it's better for app development. So if our purpose is to distribute the app, or to just lower the barrier to entry, then that Unity is the tool for the job. But we have also done Unreal, but more for like a standalone desktop app. We've also tried pixel streaming for certain use cases. One client asked for like a VR experience that we built just for that client. We used Unreal and we used pixel streaming for that purpose, but that application is too heavy to run on mobile.
Very cool. Thanks for answering.
Thank you. Really cool. Really good questions. All right. Yeah, I know we kind of went slow on the kind of the basics. Now we'll try to zip through on the more back-end stuff, or not zip through, but like quickly go over. Here. Oops. That's gonna see my screen, right? Okay. Cool. Yeah, now so we have the model imported, and so just kind of a caveat with Rhino. I don't think it does this with other softwares, but when you export an FBX, it tries to rename the layers. It doesn't like repeating names or repeated names. So like I had this layer to be just core in the Rhino model, but because I'm tracking, I have like same names under different parents, but even then it's trying to rename these to different names. So that could be slightly annoying. Yeah, even down to this level, it still it does that. So I'm just going to use the demo scene for the repo to demonstrate. Because basically we're going to cover how to bring in an FBX file, and now it's still being live linked, right? And in this scene, it's not much different than the one we just did. We did the lean touch, and we're rotating the model. The only thing that we've added in this case, and this is what you would need to do if you want to follow along, is to create a new game object, right? You can create empty, and then rename it. I think you can name it whatever you want, but I usually match the name to the script. So I'm naming it Construction Data Manager. And then I have pre-written these scripts for this demo. And what you would do after you created the empty game object, do add component and just type in. Okay, so to back up a little bit, you would need to import these scripts from from the repo. So these scripts all live under O2 scripts. So you would have to import for the Airtable thing to work. You need to import these 3 files. So if you have the repo open or the project from the repo open, you can select these files and just simply drag them over, and that'll copy it. That'll copy them. And while you're at that, you're doing that, you can just drag the whole O2 scripts folder into assets. And that should take care of all the scripts you would need to run this app. So once you, sorry, wrong window. Once you've copied over the scripts and on the game object you just created, you do add component and then type out construction data manager. And then you'll notice that these fields are empty. And so those fields you also need from the project repo. If you go into materials, you could drag over the base status fade and the base status transparent over, why don't you just drag the whole folder, all 3 materials? Do we need other? I think basically you will probably want to drag in all of these, except for the scenes one, because that's what you're working on. You can drag O2, O3, O4, O5, O6, M2, MQTT, M2, MQTT Unity, and drag them over into under assets. So once you've done that, you're ready to tie into the backend. And as I was saying, under materials, you have these materials. So basically these materials, what you saw blinking and you saw if something hasn't been done, but it's showing, we're using the status transparent material instead of the original material. And if it's blinking, it needs to be this fade material in order to change the alpha on that object, on that material. So you would just match, transparent material, drag the status transparent over, and then fade material, you just drag it over to the fade material. And then after that, you would add construction status text manager. Basically just, I don't need 2 of them. After you've done these 2 scripts, and just for, so kind of the tricky thing is, even if you bring in the buildings model, these names are a little off, right? So you would actually have to change these. I think I changed them for the most part. Okay, maybe not. Yeah, we do have an automated process in our pipeline to take care of that, but we'll do it manually this time. But so after you've done all that, you pretty much and another thing. So basically, if you hit play now, you'll start to get you'll start to pull from our Airtable. How we basically we have so right here. This is how we have set up the kind of the backend database to match exactly the file hierarchy, the layer hierarchy within the model. Right. I think I'm going to close the demo window just to avoid confusion. Chat. Okay. Oh, thanks, Arif. So if you have signed up for Airtable, you can create your own. Basically, you can start creating your own backend, and I will also show you how you can do that. This has already been set up. So, but let's say I want to just quickly start from scratch. Right. Add a new, sorry. Okay. Where's new? Oh, add a base. Yep. So basically, you once you've signed up, you can just start with the add a base, and then this basically kind of like Excel, right? So depending on what elements you want to keep track of, in our case, right, we kind of have 3 levels within the model. We have like what I call sections of the project. Sorry, let me go back to the one. So what I'm calling these, the towers, I call them sections, and then the thing I want to keep track of, the different trades, I call them elements. You can change them up however you want, but you would have to change that in the script as well. And now I can show you where that is. Yeah, I don't want to spend too much time on the scripting part, but it's probably good to know. And if you're a Power, C# user, this is should be pretty straightforward. But basically, right, in Airtable, I'm trying to match whatever is in the model, and I'm searching by the section and then element and then the floor. So that's exactly how I am searching inside Unity. And this element key here is basically, okay, the first level is section, second is element, and then floor. And then this is the syntax to find it once you have the root object referenced. So kind of go back to Airtable. I was gonna demo quickly how to, you get the idea, right? So what's really cool about Airtable is that it's a pretty straightforward tool where you just change, how you would do things in Excel, right? I think these fields are not very useful, so I'm just going to delete them. Right, floor, what other stuff? Section is the other one that I was talking about. Element, right? So, and you can, depending on your need, you can create whatever, however you break down your building. And what's kind of cool about Airtable is that you can customize these columns, these fields, by, if you click on the triangle and do customize field type. And right now they're just strings, right? So I can type in whatever I want. But imagine, you know, if this is a construction illustration tool and someone's on site and pull this up on their phone and they're trying to type, or they're trying to, you know, make sure they don't make an error while typing. It's probably best that if you can make it just a kind of a drop down for them to pick from a variety of options. So let's say section at North Tower in this case, right? North Tower, save. And then it's saved too quick. Add an option, South Tower. So these are the options. And let's say floor 1, floor 2, floor 3. In the section, you can just click right on the options you made, so that the end user, it's easier for the end user and also easier for you to make sure there's no typo and the types match and whatnot. And same with element. I won't repeat myself. So you can imagine how I kind of came about doing all these options. So, and this is actually a copy straight from a project where we were keeping track of the section and then the different elements and by the floor. And these, if you want to visualize the date, and this is, so show on built is where, as I was saying, like if I hit play, maybe I'll just use the game scene, or sorry, the scene window to illustrate. So maybe this is not really showing it. Oops. But so, oh, I think I forgot to save the changes maybe. But let me quickly change this to so this happens when you export FBXs from Rhino and decides to outsmart you by renaming everything. Anyway, so I don't know why it's not working. But basically what I was trying to say is that the show on built, so you can imagine if you're keeping track of all these different elements, right? You're keeping track of the slabs, the cores, and the glazing. So, well, in this case, the glazing is quite transparent, so it's okay even if we show like the ghosted version. But let's say it's very opaque. And if you wanna, like, let's say you wanna still show it, although it hasn't been built, like just kind of a half transparent version, it kind of like obstructs the view a little bit, right? So maybe some elements, you know, the floor plates, you can indicate with the half transparent material where things might be, but with certain elements like the glazing part, you probably just hide it altogether. So this is what this is. So if you hit no, it'll basically hide the unbuilt elements. And the key right here, which we'll get into, but you see these stats, these are basically doing like quick math on like the percentage built, right? So out of 10, let's say 10 elements of structure, how many have been done? And then it just shows you the stat. And so the key here is, so for this case, right, we have the slabs, we have the core, and then we also have glazing. And for, but you probably, in a sense, you don't need that that much fine detail in terms of, oh, you just want a stat on both core and slab to be structured, so you can categorize them in a different way in the writing. So in this case, the key kind of does that for you. Under slab and core, I categorize them both under structure. So the stats are joined for those two elements. So those are kind of the things. And also for your organizational purposes, right? So this could be just a flat spreadsheet, but that would be really confusing to organize if you have a big project. If it's only 10 floors for like a small residential project, it probably doesn't matter. But here's a pretty nifty tool where you do group, and then you can go, high to low in terms of hierarchy. First thing you pick is going to be the first parent, and then if you do subgroup, then that's like the second layer of categorization, or like layer. So basically we are matching the layer structure by grouping the different fields by the different fields. After we've done that, so if you're following along, you're still on the model and the stats aren't showing yet. And with this demo, we made it pretty easy. I'm just going to delete out. Oh, I see why it wasn't working, because I had two models. Okay. Yeah, anyway, so if I play it now, it's gonna, yeah, of course. So as I was saying, you see all the glazing kind of disappeared, right? Except for the bottom few ones, those have been done. And the glazing, like maybe from the 5th floor up, are not there because I'm making them not show when unbuilt, and only because you see these ghosted floor plates. If we should also show the glazing elements ghosted over them, then it just becomes very confusing. But okay, slightly getting sidetracked there. But in order to make the UI elements, so these stats are basically, there's two things in two different spaces in Unity. One is world space and one is screen space. So world space, and I'm sure this exists in other software too, but basically you're in the game scene, where you're in the scene, right? And the 3D elements are in the world space. And if you want to have something flat, just 2D on the screen of the app, then you would add these UI elements, right? So if you right click on orbit mode and do game object, and whatever is under the UI tab, these are all screen space elements. Well, that's not entirely true, but for the purpose of this demo, I'm just gonna go with that. So if you wanna add in, text or, a button or some imagery, that's where you would add them. And so, and also before you can make the screen space elements work, you would need a base game object. And that has to be the parent of all the UI elements you add, which is the canvas. So you have to add a canvas before you can add any UI elements. I already have a canvas here. So I'm just gonna delete that. So after you add the canvas, you don't need to change really anything here. But underneath, then you can try to add UI. In our case, we want to add some text and even a refresh button. So usually what I do is I just do like a panel. That's like a pretty basic element in UI. And then I would probably delete out the image component because, and also I totally forgot to mention this. If you click on this check mark next to the component, it enables and disables it. So if something you've done, like if you added a script and you don't want it to do its thing, you can just simply uncheck it. And then you see that with this image, basically it just disappears. And unless you have a script that controls the on and off, it'll stay in its current state until you reset it. So to speed up our presentation, we have already made the text. So if you, so after you've created a panel, I would either disable or remove the image element and then just drag from O5 prefab this construction status text, let's see, cut text container over, and that will, sorry, is that the right one? Oh, no. Text, construction status text container, okay. Your name to similarly, yeah. And then just click on this enable tab or mark. If it's grayed out, it means it's not enabled. After you've done that, I don't think you need to really do anything except, okay. Let me hide it first, just to go through the motions. Right, so I check it, it's, you're actually not seeing in the game view. I think it's probably because of the alignment issues. So what I would do is, I usually, for UI elements, I align it to a corner on the screen. So if you click on this and just click on the upper left icon, that will then align your element to the upper left corner. And then just zero these things out. Of course. Okay, I'm gonna also zero these things out. Oh, maybe the text is not up. Yeah, of course. Yeah. The font's missing. Okay. That would make sense. Okay. So if you have followed up to this point, there's some text that we need to, there's some missing font that we would need to reconnect. So under 06 UI, or whatever font, if you have other fonts, that will work too. Just drag over to the missing font under for the game, the text game object and the percentage text. And then, yeah, of course, it's starting to show up. And you can play with, you know, the positioning. And also now you're seeing that appear on the screen space. Yeah, something like that. I'm just going to make the font smaller for now. Okay. Yeah, that kind of works. So after you've done that, I'm going to delete this because I made the sample scene look better. So I'm just going to delete this and turn this back on. And now you should have the, you know, the text on screen space. And if you hit play now, oh, and also we're still tying back to our Airtable. Right. So also, if you created your own version, here's how you would find the endpoint, the URL for the API endpoint. So if you click on, if you click on help on Airtable and then you do API documentation, and go down to authentication. I think there's a step you would need to make in order to show, to have the API key generated. So if you hit the account page and go to generate API key, it'll generate an API key. And you don't really need to copy it from there. All you have to do is go to help and then authentication and do show API key. And then just copy this, forget about CURL, just copy the endpoint all the way to the bottom, copy. And so that's the endpoint of this Airtable API, right? So in our case, it's already have it all the way at the top, right here. So, and then if you want to connect to your own API, your own Airtable, replace this string, right? Whatever you copied, pasted here, then that should start talking to your URL. But before it, before your version would work, you would also need to make sure at line 125, the element key, the section. So basically, right out of the box, you wanted to, if you wanted to make it work, your Airtable also needs to have floor element and section columns. If you want to change up the names, that's fine. That would require you to get into a little bit, it's not too much, Airtable response classes. So this is just a way, basically, we've created a class to get, once you hit that endpoint, right? The endpoint we just copied. Once you hit that endpoint, you get back a string, a long string, right? So in order to parse that string to get the data out of that in a nicely formatted way, I'm just going to demonstrate I'm sure you're all aware of Postman. Right, so I've already set up with the endpoint. So this is that's the endpoint. Right. So the raw data looks something like this. And this is basically the string version of what you're seeing here on the table. And if you have a JSON parser, it'll parse it into a nicely formatted version of that. So in order for C# or Unity, they have their own built-in tool to parse that. And all you have to do is make sure whatever name you give it, you can make your own class for Unity to parse the JSON object into. And so these are the elements basically matching whatever's on Airtable, right? Floor, section, section. You get the point. So if you were to change your Airtable, right? Change the column, you also would need to change your structure in here. And you can probably ignore these two. So these are the, I guess, for the JSON to work, these are the levels above this level. And you don't really need to worry about that because I've already built that all in. All right, I think we're running a little behind. So, but you get the idea. After you hit the endpoint, you get back the data. And now getting back to Unity. Right, so basically we are able to pull in data and we're starting to, if you have set up everything nicely, it should pull straight and match, it should match your layer structure and start to manipulate however you have set it up to be. And then the glazing structure is based on whatever elements that are coming from this table. And let's say, if we change something here, and so one of the things we want to kind of showcase here is that basically we're making a passive, it's not real-time updates. When you run the script, or sorry, when you run the app, it calls the endpoint and then it pulls the data. And so unless you hit it again, it's not gonna real-time update. As opposed to what we're gonna show later today in a bit with MQTT, when you subscribe to the different topics, it live updates it in real time. So in any case, if I hit refresh, right, maybe I'll try a little bit more elements. But if I hit refresh, okay, of course it's not working. But you get the idea, like this is a more passive way of getting the data into your app. And Sheldon is going to demonstrate. Yeah. So Mike asked the question, spin up a database. Do you think it's robust enough for full app? Is it better for quick prototyping? Yeah, definitely very good for prototyping purposes. And because, the inherent technical limitations of mobile applications, you really can't include that much level of detail. So this is, kind of a quick and dumb way to, show the client the status of their project because you're not really diving into like extreme details. And, also what we forgot to mention is that polygon count, of course, is a big concern for real-time rendering. And the other one is object count. So you do wanna keep the number of objects down to a minimum if you could. If you up the object count, you also wanna make sure each object is not super complex. So I would say Airtable is quite useful and enough for purposes like these. But if you're talking about a BIM database, of course, it would be probably more error prone if you're using Airtable and not as.
I would add one thing, like in this specific example, the updates that are happening on the database side are done by our CA team. So it makes it a little easier to make these changes to a database without having anybody actually need to know SQL or anything like that. It's really easy to just get in, make changes like Excel, and like we can still hit it like if it was a real database.
Yeah, that's a really good point. So I'm sure everyone has the same struggles, right? We're computational designers, and we constantly work with design teams, project teams, and basically the Airtable interface works for them. It's simple enough. So I think as end users, you want to minimize like errors, and basically you have to design with the mindset of like, okay, if you're a baby, how would you go about using this app? So yeah, that's kind of what we had in mind. And so Melissa also asked, would it be possible to change the height of the floor in Airtable and have it updated in Unity without saving the Rhino file again? That's a really good idea. So what I was showing before, the height here is actually not to change the actual height in the model, but you could, right? Technically, if you read in the value and you just have the script, right? You wrote up a script that basically changes the height based on the data we get back from Airtable. Technically, you can change the actual height of the objects. So for this purpose, in our case, this was actually, we were showing, I think you might remember from the first slide, we were actually showing where the top of the current construction, you see the 52nd floor at whatever height. So because these models are highly optimized, and sometimes we start to lose definition, and so the heights are not exact in the 3D model, which is a shame. Like it's I think that's a constant struggle. So we constantly have to optimize through design changes, and also balancing that with having as much detail as possible, and also keeping all the metadata. So it's for visualization purposes, we try to keep the model light without much metadata. So it's not really a digital twin, if you will, but it would be nice if we can figure out a way. I know we don't have much time, but I'm gonna switch over to, I think we're at a good point, right? We can switch over to Sheldon, and he'll take us through how to tie into MQTT. So the more real-time getting the readings from IoT sensors, and you can imagine it being very applicable if like for certain CA situations, and even if you, I guess, if you're into IoT things. Yeah. Should I? Okay, maybe. All right. Okay. So yeah, pretty much just to sum up like what Tim has set up for the visualization application, we're periodically polling our database and taking those data values and using them to update parameters or update the game object that we have, the building game object. So we want to do something similar using MQTT. The difference here is that when we subscribe to a topic, we don't have to actually periodically poll the server to get new messages. That's handled by the broker as devices publish data to the broker. If your app is subscribed to that topic, it will receive that data, stays connected to the broker and tries to maintain that connection. Yeah, so on the Unity side, the only plugin that we're using is the M2 MQTT Unity plugin. This is already in the assets folder here. I more or less just drag and dropped it from its GitHub repo. I think we just need to add a link to that in our README, as well as Lean Touch, but it's a little different than Lean Touch in that it's not like an official Unity package. So it's just kind of a manual process of getting it into your project. But yeah, for the most part, we have our broker already set up. This is an AWS free instance of Ubuntu that was set up and is running the MQTT software Mosquito, 2 T's. Yeah, once that's installed, I just need to connect my clients to the broker, subscribe to the topics that I want to listen to, and then anything that is also connected to the broker and publishing to those topics, I will receive any of that data. Right. So this is our script that's handling the MQTT sending and receiving. More or less, the one topic that this visualization app is going to be subscribed to is the M2 MQTT Unity /test/hash. The hash is a wildcard which allows us to be subscribed to anything under MQTT Unity test. And on our center side, which is another scene that we have in Unity running on a mobile app, that's publishing to multiple topics based on the centers that we have running on there. Yeah, I mean, once we're connected to the broker, we will receive everything coming through topics. Right now, I have an old Samsung Galaxy S7, old Android phone that's set up with our scene. It's going to be sending over 2 topics, data from the light sensor and the proximity sensor. We'll do a little bit of processing to the data that we get just to make it easy enough to plug into Unity, our Unity objects, and then they're going to manipulate the building models. All right.
Yeah, I just wanted to bring up one thing here related to kind of what Melissa was asking. This is sort of, you can see a couple lines of the code here where it's like changing light intensity, and then here it's changing color. So that's basically just the very simplified version of data visualization that we're doing here, where parameters from, in this case, sensors are being Sheldon remapped them between 0 to 1, which is Unity's intensity values for the light. So in what you see, like that'll change like kind of the visuals that we have, but it wouldn't be wildly different if you wanted to do like you were asking about the height. So you could imagine that instead of doing a modification to intensity, you could do a modification to height for a game object, or the Z height of a game object or something like that.
Yeah, thanks. Okay, so yeah, on our receiving app side, that's more or less the bits and pieces as far as MQTT. And when we hit play, we are pulling Airtable periodically, pulling that API, but we are also connected to the MQTT broker, and we're listening for messages to be published over the topics that we have already subscribed to. And now the second bit of the this whole I should not save, right? Second to last. Further down. Oh, it's on. Okay. Oh, that's good. All right. So this other scene next to the orbit mode seat, the sensor to MQTT, is more or less a plate. Like we're using the sensors on the phone to take place of IoT sensor, air quality sensor, light sensor, etc. And all this is really doing is just pulling the sensors for on the phone, and then publishing those over MQTT to specific topics. So in our sense something script, I just have topics set up for all the sensors that we can sense. Again, just for the demo, we just used the light sensor and proximity sensor, but there are a range of sensors that you can get information from depending on the device that you're using. And from there, they're just publishing, after it reads, it's just publishing the data to the specific topic. Yeah. So publishing app or like this sensor to MQTT app, I'm going to I've already built it out on the phone, but I can try to see if we're able to do that. Oh, you're not on Android. Hopefully it doesn't take too long, but yeah, we do want to be on the Android platform. It would be like if you're on a Mac, it would be possible to build an app like this on iOS. There are less sensors available on iOS, but on Android, it's available to
So yeah, anyone following along, if you don't have a phone set up to build on Android or anything, that's A-OK. You can just stick to the orbit mode application. That's really where we'd be doing any visualization or anything like that. I'm just going to build and run our sensing app.
Again, to Sheldon's point, this is the process of how you could test build to your phone or mobile device. If you have an iOS device, you would need a Mac to build from. But the process is quite similar. You just hit build, and with the Mac, with the iOS devices, you would also need to install Xcode, and you would open up the whatever it's been built out. I think it's a WC project or workspace file, and then that'll open up Xcode, and then you would hit run, and then it should build to your phone to test. And we have built out, or we have published iOS apps and Android apps in the past, and it's Unity really makes it easy for you to do that, and you only really need to make the project once, and it could run on both devices. There are some little nuances that you need to navigate, because after all, these are very different devices, Android versus iOS. But yeah, I mean, you'll get there once, you'll cross that bridge once you get there. But it is a pretty nice tool to master. All right. So we are built out, but just going back to our visualization application. So right now the center is hooked up. It's up and running. It is publishing data. And now that I'm hitting play on our visualization app, it should also be connected to the broker or to the server. And again, anything that's coming in over those topics are going to get published or are going to get received, processed, and then Unity is going to manipulate game objects. And right now we have the light sensor tied to the light intensity of the directional light. So the values from the light sensor, you see they're darker as I put the phone in a darker section. And then we also have the proximity sensor to change the color of those buildings as the proximity sensor gets triggered. So the way the app is working is we're not hitting a server periodically. We're staying connected to the broker, and we really just have to keep that connection alive. And as data comes in, everything will be updated. There's really no need to continuously pull a database to get any changes or anything like that. Yeah. Let's see. No, that's it for the demonstration. Yeah. I don't know. That's you already touched on the oh, well, yeah, I mean, the broker that we have set up now is like something we had spun up for this demo. Again, it's a free tier on AWS VM that I installed Mosquito broker on. There are a lot of different types of software that you could install to use as a broker. And AWS and Google, Microsoft also have their own services. Like very often it's what they use for their IoT service packages. So it's relatively easy to have a broker set up. And Eclipse also provides a test broker for like kind of situations like this, development situations like this. But as long as you have the broker address and the port, you can broker address and the port, and depending on how the broker is configured, you might also need a username and password. It's also possible to use authentication keys as well and encryption. But we just have this set up as an anonymous broker. Anyone can connect and publish and subscribe to topics. Yeah, I mean, that pretty much concludes our workshop. But just before we get into Q&A, I also kind of want to talk about the IoT portion of this workshop, right? So right now, the input process of tracking construction is quite manual, as you can see. I mean, we're using the app to keep track of things, but still it would require a CA team to manually input on a spreadsheet, so to speak, right? Basically manually manipulating the data. But as you know, IoT improve, devices improve, you can imagine a scenario where you can probably detect what's been installed and what's been completed, and that process can be automated. And then so one day, what we're showing in the second portion versus the first portion, that process can kind of blend together and be automated away. But we are in an archaic industry, so we don't know when that's going to happen. So in the interim, Airtable and all these kind of easy to spin up tools make sense to meet our kind of day-to-day needs. Of course, it has its limitations, and we're quite aware of those. But yeah, we're constantly looking for interesting solutions to solve our daily tasks and whatnot. And we also maybe like to open up the floor for comments and for questions, because I don't know if this is interesting at all to you guys. Maybe you were expecting something entirely different. And of course, it would be great to hear questions or feedback, and we'll try to address them.
Thank you so much, guys. This is an amazing workshop. I'm very newbie to Unity. That Tim knows. Usually I leave it to him to do the AR and the Unity side of the things whenever we are working together. But I was able to basically get the project from GitHub and able to load all the packages and able to run. Thank you so much. It's very interesting, very deep learning. That's definitely spark a new ideas for either hackathon or the future projects for the participants. I'm sure they will be very useful. Thanks again.
Thank you, Alchin, for the kind words. Always supportive of our causes. Yeah, thank you again for attending.
Of course.
Thanks for staying awake. Any other comments, questions?
Tim, I saw you on the Speckle call this morning. I'm curious if you had any ideas about how to use Speckle in this context, and if you've considered using that as a way to import live data.
No, that's a really good question. I do see a lot of overlap in terms of just use cases and whatnot. I think, and even the web browser on Speckle looks pretty good. I think they're just, you know, there's always some kind of internal needs for, you know, one-off applications that are very specific for like certain visualization needs. And sometimes it's actually quicker to do it in your own ways in Unity, right? Like you just build out an app and you can like just sideload it onto, you know, the partner's phones or whatnot. So yeah, Speckle looks really promising, and we did look into that a while back, and now they've improved tremendously. I would be, yeah, and I saw that they have both the Unreal and Unity plugins, so those look really promising. One thing that we keep kind of running into is that on a lot of the construction sites, there's no internet reception. So that's always a challenge, right? I mean, even with the Airtable solution, it wouldn't work without reception, but that's kind of a constant. Yeah, we just kind of keep going back to the same problem where, you know, without the cloud, a lot of the apps just don't work. Anders has a question.
Yeah, I can maybe say it out loud. Thank you very much for your great work. My question was more like why you chose MQTT over other tech like WebSockets, but mainly I would actually like to ask something else. So say you have a 5-year project on site and you installed sensors and they gave you like a year to build the perfect backend. Like what changes would you do to your backend compared to the backend that you showed today?
All right, yeah, thanks, Andrew. It's a really good question. As far as MQTT versus WebSockets or HTTP, the general like the decision would kind of be on the use case. For the most part, MQTT would be good for anything that is constrained to battery life or power usage or bandwidth. And it actually is possible to use MQTT over WebSockets as well, especially if you are connecting through a web browser. And at least as far as the IoT devices, that MQTT stream works really well as a backbone to ferry messages throughout the whole network. So that can be from a device to application or to a processing script to database. It can kind of go all over the place. So it really wouldn't be like the whole backend, the whole backbone, or the whole bit of the backend. It's more like, again, like that backbone of just ferrying things around. So even if we did have a big project with a lot of sensors, if they are on using like MQTT as one of the messaging or one of the ways to relay data, it would make it, it would be easy to tie in other databases, other applications to that stream, be able to grab that data, process it, put it back in the stream, put it on a database. It's pretty versatile in terms of that and being able to work with other applications and kind of build things up around that.
If you were to, if you had a database where you kept the historic records for your IT data, would you then still prefer serving it to the client via MQTT, or would you choose some other way?
So what we do right now is the data that we get from sensors that are constantly posting data, we do have an ingestion script that will take all of that data and put it into the database, so that if we do want to pull up historical database, we would then do an API call to get the historical data that way. MQTT is more just for live data, like what's happening right now, or like getting status, what devices are online, and all of that. But we for the historical stuff, we do use like the API, like web API. But all of that is still like ingested through the MQTT stream. Yeah.
Okay, thank you very much.
Are you guys supporting a number of clients with this kind of technology, and what are, you know, some of the services clients are looking for? Is MQTT supporting like ongoing maintenance of or operations within buildings, or is it a nice add service during construction of a high profile project to kind of, you know, have a 3D construction process? Or are we just touching the iceberg here of much larger applications that you guys are servicing out of shop?
Yeah, like I don't really think we're directly using, like at least right now, like using the MQTT protocol for any like client-facing applications or anything like that. And yeah, like again, like IoT industry is still really in its infancy. So even something like MQTT was taken as repurposed of sorts and turned into something that is like kind of now a standard. But the bigger companies, Amazon, Samsung, Google, are creating their own protocols. It's called Matter. So there are still like kind of building up all those protocols around IoT devices and IoT control to kind of like work with, to just work better with the consumer devices and also work in industry.
And as I understand the space, if I understand it correctly, I think there's, you know, all these different solutions out there that target like really large projects. And then there's also the consumer grade IoT manufacturers and, you know, or resellers or whatnot, but there's really nothing in between. And so we're kind of exploring, you know, like our in-house solutions to kind of target that void. But yeah, it's not, we're, you know, we have sensors in the office. We're constantly trying to, you know, find use cases for these, and we present them to clients and see, you know, trying to see what sticks with them. But yeah, we're, it's kind of still in the experimental phase, I would say, right?
Yeah, definitely. And for the most part, there are very often even bridges of sorts to bridge certain protocols. So if you have any wireless protocol, LoRaWAN, building network controls, like there are ways to kind of tie in these different services to each other, and that's kind of part of the challenge in an IoT platform, is to be able to agnostically move around data and kind of work with different protocols.
Any other questions? Wow, we used up all our time. Thank you for coming, guys. Yeah, if you have any more questions, I guess we still have the Slack channel. Yeah, feel free to shoot us any texts, any questions, any comments you have. It's been really fun to host this workshop.